Chapter 1, Section 2, Points, Lines, and Planes. What is a point? A point has no dimension. It is usually represented by a dot. In the parentheses, there's a dot. That's how we represent a point. A point has no dimension, so there's nothing actually there. It's just to show you a location. What is a line? A line extends in one dimension. It is usually represented by a straight line with two arrowheads to indicate that the line extends without end in two directions. Again, in the parentheses, this would be a line. It's a straight line with two arrowheads. A line extends without end in two directions. We're kind of limited because we have to show it on paper. But if you can imagine a line that goes on forever and ever and ever, that is truly a line. What is a plane? A plane extends in two dimensions. It's usually represented by a shape that looks like a tabletop or wall. Imagine that it extends without end, even though the drawing seems to have edges. Just like a line, we're limited because we have to represent planes and lines on paper. So in my parentheses, I have a shape that looks like a parallelogram representing my plane, and notice that it does look like it has edges. An example that I like to give to help you start thinking that a plane does not have any edges, we live in Oklahoma where the wind comes sweeping down the plain. Our land is very flat here. So if you imagine that you're standing in the middle of a field, take out all the little bumps and everything, make it completely smooth, that would be a good idea of what a plane is. It goes on and on forever in every direction. You could not see the end of the plane. Collinear points are points that lie on the same line. So in the picture, I have a line with two arrowheads on it. That's how I know it's a line. And if you notice, point A and point B are both on the line. So A and B are collinear. Coplanar points are points that lie on the same plane. Here I have a plane represented by the parallelogram, and I have points A, B, and C. If you notice, points A, B, and C are all on the plane, so they are coplanar. The first example, A, asks us to name 4 points that are coplanar. If you look at the picture they've given us, we have a plane represented by the rectangle, and then there are 2 lines extending through the plane. If you notice, L, N, and O are all on one line going vertically through the rectangle. That line would actually be on the plane. If you notice this line that's kind of diagonal through the picture with point P and point N on it, if you look to the right of point N, it's a dashed line or dotted line. That means that the line is there, but it's actually behind the plane. So it's not on the plane, it's behind a plane. It's kind of hard to see a picture and know what it's talking about. So we will definitely do some examples or have done some examples in class where I actually show you what this looks like in real life. But for right now, just imagine, if you can, that this point, this line with P and N on it, if you can imagine that you have a piece of paper and you've poked a pencil through it, that would be what that line would look like. So A asks us to name 4 points that are coplanar. Well, point P, if you notice, is not on the plane. It's outside of the plane. But we do have points L, M, N, and O are all on the plane. B asks us to name 4 points that are not coplanar. Well, point P, if you can tell, is outside of the plane. If we put point P with any 3 of the points that are on the plane, that makes it not coplanar. Only 1 point needs to be off the plane to have it not coplanar. So I'm going to put L, M, N, and P, but you could have done P with any 3 of the other points, and they would be not coplanar. C asks us to name 3 points that are collinear. Well, we have 2 lines on this in this picture. We have the line with P and N and there is not another point given on that line, so we cannot name 3 points that are collinear from that line. But if you look at the line going vertically, we have L, N, and O all on that line. So 3 points that are collinear would be L, N, and O. A line segment, or just a segment, this would be an example of a line. We have the 2 arrowheads with points A and B on it. And this would be an example of a line segment. If you notice, I've taken off the arrowheads. A line segment ends at 2 points. A line extends through 2 points. To notate or show that we're talking about a line, we're going to use 2 points on the line. So in this case, I have AB, and I draw a line with arrowheads over it to show that we're talking about a line that extends. To notate a segment, we do, again, 2 points on the segment, AB, but in this case, I'm not going to use the arrowheads because it is not a line, it is a segment, if you can see the difference. The difference between a line and a segment is that a segment ends at points. It does not extend forever. A ray has an initial point and extends in one direction. So a ray, this would be an example of a ray. If you notice, it starts at point A. It doesn't go past point A. It starts there. And it extends through point B. So the initial point would be A, and it's going to extend through point B. How we notate this would be 2 points on the ray, A and B. One of them needs to be the initial point. Okay, usually you write that first. In this case, the initial point is A, so I wrote A first. If you notice what I've drawn over my AB, I have a line with no arrow over A, and then over B, I've drawn an arrowhead showing that it extends in that direction. It is important that your initial point does not have the arrow over it, and that the direction in which it extends is where the arrow is in your notation. Opposite rays are 2 rays that have the same initial point but extend in opposite directions. In this, I have 2 lines that are crossing at X. They're intersecting at point X. If you can see, my opposite rays would be XM. My initial point is X, extending through M, and XN. If you notice, ray XM and XN put together would form a line. Those are opposite rays. Then my other set of opposite rays would be XP and XQ. Again, they're both initial points are X. XP and XQ, the rays, would come together to form a straight line. The next example asks us to draw 3 collinear points A, B, and C. Draw point D, which is not collinear, with A, B, and C. And then it asks us to draw line AB and ray BD. If you notice, I know that it is line AB because there are 2 arrowheads in the notation. If you notice, I know that it is ray BD because there is not an arrowhead over B. That needs to be my initial point, and it's going to extend through D. I already have point D on my paper. I need to draw 3 collinear points A, B, and C. Then I have point D that is not in a straight line with A, B, and C. And then I'm going to draw a line extending through points A, B, and C to make that line AB. And then I'm going to have a ray with its initial point at B and extending through point D. Your picture does not have to look exactly like this picture. There are several different ways that you could draw it, but you should have at least a line and a ray, and your ray should be starting at B and extending through D. The next example asks us to name two pairs of opposite rays in the figure. One set of opposite rays, if you look at the points, remember we need 2 points to name a ray. So I need to start at point F. One ray extending off of F would be to the left, which would be ray FE, and then to the right, which you could either name that ray FG or ray FH. It doesn't matter. The other set of opposite rays would be starting at point G, and you can extend to the left, and it could either be ray GF or ray GE. And then to the right, you have ray GH. Notice in my notation that I have F first in the first set of opposite rays in both notations because F is the initial point, and then I have the arrowhead extending in the direction. So FE is pointing to the left, FG is pointing to the right, but in my notation they both look the same, and that's fine. Intersection. Two or more geometric figures intersect if they have one or more point in common. Two lines are going to intersect at a point, and two planes, this picture is kind of hard to understand. Again, I've either already shown you an example or will show you an example tomorrow. So here I have one plane, and I'm going to put another plane through it, and these two planes intersect at a line. One thing that you can look at right now, if you look at your wall and your ceiling and let those be two planes, so let your wall be one plane and your ceiling be another plane, where they intersect, you can kind of see a line. There might be some crown molding there, or your paint color might change, and that's forming a line. Draw a line and a plane that do not intersect. Again, this picture might be kind of tricky. I'll show you an example tomorrow in class. A line and a plane that do not intersect. So here I'm going to have a line, and here I have a plane. If you can imagine in this picture, if you can imagine you have a table or your desk or a piece of paper laying down flat, and then if you can imagine that you have a pencil above it and it's going horizontal, that would be what this picture is depicting, and I will show you an example of that tomorrow. The next example asks us to draw two planes that do not intersect and a line that intersects each plane at one point. This one gets kind of tricky. Two planes that do not intersect. So I need to have them be two parallel planes because parallel lines or planes do not intersect. And then a line that intersects each plane at one point. I'm going to start with the two planes. If you can imagine that you have two pieces of paper kind of standing up, or two books kind of standing up, and then a line that intersects each at one point. So this line is going through. If you can imagine you have a pencil and you've poked a hole through both pieces of paper, and then you have those two pieces of paper not touching on the pencil. That's kind of what this picture looks like. Again, kind of hard to tell. It takes a lot of practice, and it takes a lot of seeing real examples of this. So I've either already shown you an example or asked me to show you an example of this in 3D in real life. Today's assignment is on page 13. It's numbers 10 through 50 even, 55 through 56, and 73 through 75.